Hi. In this video, we are going to discuss assignment number 8. Okay. So let's start with the question number 1. In question number 1, we have to find points of relative extrema and the interval on which the function is increasing and those on which it is decreasing. Okay. Let's start with 1a. See, fx is equal to x square minus 3x plus 5. Then f dash x, this is differentiable on all of R. So f dash x will be 2x minus 3. Okay. And now you check where f dash x is greater than 0. You will see that f dash x is greater than 0 if 2x minus 3 is greater than 0, that is 2x is greater than 3, x is greater than 3 by 2. So from 3 by 2 to infinity, f is increasing. Okay. And where 2x minus 3 is less than 0, this is less than 0 where it is less than 0 if x is less than 3 by 2. So from infinity to 3 by 2, it is decreasing. Okay. So graph is something like this. Okay. And from 3 by 2 to, okay. So you calculate the value at 3 by 2, and there you will see first it is minus infinity to 3 by 2, this is decreasing, and from 3 by 2 to infinity it is increasing. Okay. So at 3 by 2 we will have a minima. Okay. So we have a relative extrema which is minima at x is equal to 3 by 2, and from 3 by 2 to infinity it is increasing, and from minus infinity 3 by 2 it is decreasing. Okay. Okay, so the result I'm using is this one. If f from I to R differentiable, f is I is interval, and f dash is greater than 0, then f is increasing on I. This is what I'm using. And uh, similarly, if f dash is less than 0, then f is decreasing on I. Okay. You check out my earlier video. There I have given proof for one of these. Okay. So this concludes 1A. What is the next question? Let's go to 1B or 1C. Which one do you want me to do? 1B is of similar type. Let's do 1C. Okay. Okay. 1C. Let me check. This is root x minus 2. Root x minus 2x plus 2. Okay. X is greater than 0. Okay. So, how do you differentiate? Is this differentiable? Yes, it is differentiable, and this will be half x minus half minus 2 half x plus 2 minus half. Um, I'm using chain rule to differentiate this one, and I'm using this. If you differentiate n x to the power n, you will get nx n minus 1. Okay. And chain rule I'm using here to differentiate this. Okay. Okay. So let's see. F dash x is equal to half x minus half minus x plus 2 minus half. Okay. So this, and then 2 root x plus 2 x plus 2 minus 2 root x. Okay, what do we do now? Okay, so see, if you take root of something, let's say root of 4, then it is 2, not minus 2. Root of 4 is not defined to be minus 2. Okay, this is wrong. So root of 9, you will say 3. Root of 9 is not equal to minus 3. Okay, so this is just definition. So here also, if someone asks root x, then these are all greater than equal to 0. Okay, so it is not never negative. Okay, so these two are positive. Okay, so I want to see where it is increasing. So we will, I want to check where f dash x is greater than 0. Since these two are positive, these two are positive, I just need to check the sign of this one. Okay, so let's see where it is greater than 0. Okay, so this will be x plus 2 is greater than 2 root x. Okay, can you square it? Yes, you can. So this will give x plus 2 is greater than 4x. Okay, and now 2 is greater than 3x. So again, this will be 2 by 3 is greater than x. So what I get is x is less than 2 by 3. So if x is less than 2 by 3, then uh, okay, so from we have from 0 to, okay, so from 0 to 2 by 3, we have f dash x is greater than 0, which means f is increasing on 0 to 2 by 3. And similarly, you check f dash x is less than 0, which means x plus 2 minus 2 root x. This is less than 0, plus 2, 2 root x. Square both sides, you'll get x plus 2, 4x. Okay, x cancel 3x. 2 by 3 is less than x. So for x greater than 2 by 3, f is decreasing from 2 by 3 to infinity. Okay, so at 2 by 3, what values taking? You check on your own. So some value, and 0 to 2 by 3, it is increasing. let's say something like this, and then it is decreasing, right? So Extrema at 2/3, increasing from 0 to 2/3 and decreasing is okay. Uh, okay. I hope you can do question number D on your own one day. Now let's move to question number 2. We have to use the mean value theorem to prove that for every xy belongs to R, this inequality is true. Okay. So see, go to question. You have to prove this sin x minus sin y is less than x minus y for all x y belongs to R. Okay, how do you do it? Let's take fx is equal to ft is equal to sin t, and we will do it on interval xy. So you know sine is differentiable on this function is differentiable on all of R. Okay, so it is certainly differentiable on this smaller interval xy. Okay, so mean value theorem says that and it is also continuous. So if a function from a b to R let's use the this convention x y what f continuous on xy differentiable on this, then there exists C such that f dash C is equal to fb minus fa by b minus a. Okay, sorry, fy minus fx y minus x. So I'm going to use this. What is f dash c? F dash c in our case will be this is cos c, right? Because differentiation of f is cos, so f dash c will be cos c. Okay, so cos c is equal to sin y minus sin x by y minus x. So this will get sin y minus sin x is equal to cos c y minus x. Okay. Now if you take mod, this will be sin y minus sin x. This will be cos c y minus x. Okay, now use this property of mod. Mod ab is less than equal to, this is equal to mod a mod b. Okay, mod a mod b is equal to this inequality I'm using here. So this will be cos c y minus x. And now also use the fact that this is equal to less than 1. Okay. So this property I'm using y minus x. So sin y minus sin x is less than equal to mod y minus x. Okay, so this one is done. Question number 2. Okay, let's move to question number 3. F is twice differentiable. Okay, and from 0, 1 to R. And what is this? F dash x double dash is less than 0 for all x belongs to 0 to 1. Okay, and phi 0, 1 to R given by phi x is equal to fx plus f1 minus x is increasing in 0, half and half to 1. This is what we want to prove, right? Okay. Uh, so, uh, how do you prove something is increasing in an interval? You use this theorem, right? If f dash x is greater than 0, then phi x is increasing. Okay. This is what we are going to use as. Okay. Okay. Provided phi is defined on an interval and phi is differentiable. Okay. So this theorem is what we are going to use. So first see that phi is differentiable. Why? Because f is so and f is differentiable, so it implies phi dash x is also differentiable. Okay. Okay, so there will be minus 1 1. Okay, so this is minus pi dash 1 minus x. Okay. Okay, now see that from x to 1 minus x, see this. This is 0, this is 1. Let's say your x is smaller than 1 minus x, let's say. So which means uh okay, so what I want to say is this one. If your x belongs to 0 to half, then x is less than half, which means 2x is less than 1, which means x is less than 1 minus x, right? So, okay, okay. So, this is what I'm going to, if your x belongs to 0 to half, then this holds true. So let's say x is here, then 1 minus x is somewhere here because it is greater, right? Okay, so I want to use mean value theorem on this interval. Okay, for f dash. Okay, I can do that because f dash is also differentiable. It is twice differentiable, right? So f is twice differentiable, so f dash is differentiable as well. So you can use it like this. Sorry, 1 minus x, then x by 1 minus x minus x is equal to pi, sorry, f double dash c. Okay, so there exists c belongs to 0 to 1. Sorry, belongs to, okay, so it is in 0 to 1. Actually, it is in x to 1 minus x, but which means since x and 1 minus x 1 minus x is inside this 0 to 1, so actually this belongs to 0 to 1. So f dash c is equal to f dash 1 minus x minus f dash x 1 minus 2x. Okay, uh okay, so see that from here only, if you take x this side, then you will get 0 is less than 1 minus 2x. So this thing is positive, and f dash is always negative, right? Let's go back. Okay, here f dash is always negative. So this is negative and this is positive. So you will get what? Negative, right? So this thing is negative. And so this will be 1 minus f dash 1 minus x minus f dash x. This is less than 0. I took this here. So this thing is less than 0 because this thing is less than 0. So now you use it here. Okay. So you since this is less than 0, so f dash x minus f dash 1 minus x, this is greater than 0, right? So this thing is greater than 0. This thing, right? I'm using this. So f dash x is greater than 0. And which x, for which x this is greater than 0? For x belongs to 0 to half, right? I took this assumption. Okay. Now let's say x is between half to 1. I will show that f dash x is less than 0. That means it is decreasing. I will show this. Okay. How do I do it? Again, same. X is between half to 1. Then 1. If you add 1, this will be 3 by 2. Wait, let's wait. No. Okay. X is greater than half. So 2x is greater than 1. So x is greater than 1 minus x. So this time from 0 to 1, we'll see that x is here and 1 minus x is here. This one is greater this time. Okay. Okay. And x 2x minus 1 is greater than 0. Okay. From here only. Okay. So we will use this. Okay. Now again, if you use mean value theorem on f dash, you can use it because f dash is differentiable. F double dash exists. Okay. So this is differentiable and this is differentiable. It's also continuous as well, right? Because differentiability implies continuous. So this thing is there and I'm going to use it on 1 minus x 2x this interval. So then it will give me there exists c belongs to 1 minus x 2x. This is round bracket. Okay. Does that f dash c is equal f double dash c is equal to f x minus f minus x by x minus 1 plus x. So this will be uh, I ignored make this correction. This is f dash. Okay. So you will get f dash minus f dash 1 minus x 2x minus 1. Okay. F double dash c. Okay. Again 2x minus 1 is positive and f dash c is negative. This is positive from this and f dash c is given to be negative. So this will be negative, right? So less than 0. Less than 0. So you take this thing here, here. Use this thing. This thing is negative. So this thing is negative. So phi dash x is less than 0, right? When x is between half to 1. Okay. So we have shown that what we wanted to show. So this concludes question number. What is this question? 3. Okay. Now let's go to question number 4a. Okay. What is this question? Riemann sum for x cube minus 6x interval 0 to 3. So this okay. X cube minus 6 n is equal to 6 right hand point and 0 to 3. I hope I have noted the correct. Let me check again. X cube minus 6x 0 to 3 n is equal to 6. Okay. So now let's do it. Uh, what do you do now? Okay. there is 0 to 3. If you divide it equally into 6, then this will be half, 1, 3 by 2, 2, 2.5. Okay, okay. Mm, uh, okay. So let's say we will take this endpoints 0 to half. We will take right endpoint, right? Let me check. Right endpoint. Okay. Uh, this is the formula FCK delta XK. K is equal to 1 to 6. Okay. So remember that x0 is equal to 0, x1 is equal to half, x2 is equal to 1, x3 is equal to 3 by 2, x4 is equal to 2, x5 is equal to 2.5, x6 is equal to 3. Okay. Now, okay. So, and C1 is equal to half, C2 is equal to 1, C3 is equal to 3 by 2, C4 is equal to 2, C5 is equal to 2.5, and C6 is equal to 3. Okay, so this is my first interval and right endpoint C1 half. Okay, second interval, right endpoint is 1, right? This is my first interval. Second interval is half to 1. Right? Okay, so let's now put the values. F half and delta xk is always xk minus xk minus 1. Okay, but in this case, for every k, you will get half only because they are equidistant, right? Every interval has gap half. Okay, so this is half. Then f of 1 half plus f of 3 by 2 half plus f of 2 half plus f of 2.5 half f of 3 half. Okay, I hope this is correct. Let me check again. It's fine. Hmm. Okay, so you take half common and then f half will be half cube minus 6 into half plus 1 cube minus 6, 3 by 2 cube minus 6, 3 by 2, 2 cube minus 6, 2.5 cube minus 6 into 2.5. Okay, I hope you can do this on your own. This is fine, this is fine. Then this will be 3 cube minus 6 into. Is this correct? I think it's correct. Okay, now you, I think you can do it on your own now, right? Okay.